Fantastic. And thank you, Dr. Drummond, for having me be a part of this with you. And congratulations to you all for your pending graduation. I think it's really awesome that you've been able to make it through. For what it's worth, I'm not a doctor, obviously. I don't work in medicine, but I do have one brother that is a practicing medical doctor, and I have another brother that's a pharmacist. So I'd like to think that I've still been a little bit of medical information from those folks, but if you do end up asking any questions, anything medical related, I'm just going to stare blankly at you. That being said, thank you all. So Dr. Drummond and I met maybe a month or two ago. We both were attending a heat summit that the county put together, and we were discussing challenges surrounding heat and that sort of thing. So Dr. Drummond and I talked a little bit afterward, and he talked about how he was starting up this elective for you all, and asked me to present some information that I might have. So here I am, and we're going to be talking a little bit about severe weather, which is a very broad topic, and certainly can't really cover very extensively in 25 minutes or so. So we're going to take just a very cursory touch at a couple of topics. And you do see, assuming you see my screen here, you should be able to see like a QR code. There will be a couple of interactive activities or just questions, polls that I'll ask of you. And if you don't have a phone in front of you and you can't scan it, I do have a URL that I think I can chat in here too. So it's the same URL. That QR should take you. So I've got a couple of questions that I'll be asking along the presentation related to severe weather. But again, this is a very broad topic, and I know through your roughly 2-week tour through this course, you're already going to be talking about a lot of different climate change topics. You just heard about extreme heat, so I'm not going to be touching on that today. You'll be hearing about air quality, precipitation, that sort of thing, which are very closely interconnected, so I won't be touching on those either. But I will hit on very briefly extreme cold, severe weather in the monsoon, and kind of a fun topic from my perspective, ocean circulations, which is something that I did my senior thesis project on like forever ago. So if we're ready to get started, hopefully you have that website from the QR code, or you can hit the link in the chat here. We'll go ahead and move forward. And we're going to start with extreme cold, and we're going to start with a poll. And feel free, Dr. Drummond, to participate if you want to be a part of this exercise too. So again, this is the first poll, and let me see if I can activate it here. Okay, it should be activated, so you should see on your screen a poll question now. With increasing climate change and global warming, should we expect to see more frequent or less frequent extreme cold events? And you have a multiple choice of more frequent, less frequent. Is this a trick question or the shruggy? So go ahead and just quickly give your best guess there. And I can pop on the screen. Hopefully you should be able to see some of those poll results on my screen right now. Looks like a good chunk is going with more frequent extreme cold events. Quite confident, folks. A few of us are going with less frequent extreme cold events. No shruggies. Nobody thinking this is a trick question. So we'll go ahead and move forward with the presentation. And step us through a few extreme cold events that have happened actually just in very recent history. Perhaps the most memorable, and maybe just a quick show of hands since a lot of people have their webcams on. How many people are aware of this February 2021 event in Texas? We've got a few hands. Okay, terrific. Not complaining about that. So this was a mid-February event in 2021. It lasted about a week in Texas, and you can see the graphic on the bottom right there. The entire state of Texas and much of the Deep South ended up in a winter storm warning, mostly for the extreme cold that occurred that event. What was really noteworthy about this Texas event was that it was so cold that a good chunk of the state of Texas lost power. At one point, over 10 million people, which is, I don't know, something like a third of their population, was without power, many of those folks for several days. And that's what really hit the airwaves with that, was because there were so many people without power for so long. And like one of the big reasons why was because the infrastructure of their energy system is just disconnected from the rest of the United States. So nobody could come in and actually help them. They were just on their own. And because of that and the extreme cold, some of the after effects were 246 people that were confirmed dead with that. Some estimates as high as 702 deaths related to this event. Severe traffic accidents. There was a 100-plus car pileup, which included fatalities. That was in the Dallas metro, I believe. And then you think about some of the downstream impacts of having really difficult to traverse roads. That led to a lot of people not being able to access groceries. There were like severe run-ups, like in the grocery stores, pillages, that sort of thing. Estimates were potentially in the 80 to 130 billion dollar, talking about the economy in terms of direct and indirect economic losses. It's estimated to be the most costly winter storm in history was this event. And again, this was just 3 years ago, 2 to 3 years ago, in a global warming world. So next example was literally a year later, December 22 to 28 of the following year. There were 106 deaths attributed to this event, but what really became noteworthy is actually a fairly similar event. It impacted very similar areas. But what was really noteworthy about this event is that the airline system really became crippled because of this. I won't mention names of which airline was severely crippled, but it is the opposite of Northeast. And they had significant issues catching up with the airlines. And actually, I read into this a little bit. It started in Denver. That's where the issues really started. And then because the storm system moves from west to east, all of the downstream impacts with the airline system went from west to east there as well. So, over 7 million people lost power with this event. But more noteworthy, 18,200 flights were canceled. Roads and highways were impassable for days. There were blizzards in Buffalo, and they couldn't travel for 5 days. My brother was actually impacted with this personally. He was staying with me here in Tucson during that Christmas holiday, and then had to make it back to DC. And his flight on the opposite of Northeast got canceled. So he ended up having to rent a car and having to drive cross country for a very significant expense just to get across. So this was another very significant event. I didn't see economic impacts, but with all of those flights canceled, you knew that it had to be a really huge deal. This past winter, you may not even think about it, but if there are any football fans here, this became kind of a noteworthy media event. And Dr. Drummond and I talked about this a little bit when we last met, but I am a Kansas City Chiefs fan, so I'm going to throw my hat on here. Go Chiefs! We won the Super Bowl. This event became very noteworthy because it was actually surrounding, this game was played surrounding the most significant winter event from this year, and 95 deaths were attributed to this event. But this became noteworthy because it was the fourth coldest football game on record, and they ended up playing it anyway. And I started seeing statistics after the fact. It's nothing official, just kind of anecdotal data. But there were at least dozens of frostbite cases that ended up with amputations of fingers or toes or that sort of thing, all attributed to just people attending this game. So even in just the last 3 winters, we're talking about 3 very significant extreme cold events. So you can kind of see where we're going with the original poll question, that yes, climate change does lead to extreme weather. And I took my hat off. The reason why is because there's growing evidence. You may all have heard about this polar vortex, and it's something that like the media folks just like catching onto terms, and polar vortex is one of those. So basically every extreme cold event now in the United States is a polar vortex, whether that's fair or not. But what we've learned with research of climate change, that the long story short is that the change in climate is actually destabilizing this polar vortex. it makes it more unstable and more likely to bring down cold polar air from the North Pole during the winter time. So the answer to the question is yes, there are more extreme cold events, even if that means in a global warming world, we're seeing fewer like regular type cold events. That's kind of a big deal, right? So, and it's kind of important too, because as we kind of heard about before, there's a lot of efforts in the community now that are all focused on global warming, building resilience to heat. Like I was literally at a meeting with the Pima County Public Health Department yesterday, and we were talking about, building resilience to heat. What do we do to support these communities during these extreme heat events? Nobody's really talking about cold events anymore. And that becomes a problem when we're having more and more extreme cold events because of this. So it's just something to think about as you all will be, practitioners or researchers in the community moving forward. We're focusing all these efforts on heat, where we can't really drop the ball on all of these other climate change concerns, because in a lot of ways, just with climate change, anything that's what you're seeing right now, you're just seeing more extreme versions of that. The wet areas are going to see more extreme wetness. Dry areas are going to see more extreme drought, and so on and so forth with heat and cold. Okay, we're going to move on to severe weather and monsoon first. I'll take a quick break though. Are there any quick questions about extreme cold? Okay, great. We'll lead off with another quick poll. So let me activate that real quick on your phones. Give me a second. Okay, you should see this poll now, and it's a very similar question. Increasing climate change and global warming, should we expect to see more frequent or less frequent extreme severe weather events? And here we're talking about thunderstorms, tornadoes, that sort of thing. And I guess I should say I probably answered that question with my previous response, but everybody's gravitating toward the same answer. And if I had to answer it right now, I would actually say it might be complicated. And we'll go into that here in a little bit. But kind of interesting question here. And I'm kind of saddened that nobody's using the shruggy. Like I kind of want to see someone pick the shruggy in one of these questions. But we'll move on forward here. So just kind of building this in a little bit, we'll talk a little bit about what the ingredients are to a thunderstorm. You all don't study this. I live and breathe this stuff. So just giving you like the very simple atmospheric sciences 101. There's really only three ingredients in the making of a thunderstorm. Moisture, obviously. You need some sort of, you're going to rain out of it. So you need some sort of moisture to build that thunderstorm cloud. Lift, which is something we don't really think about, but you need to get that moisture from the ground level up to the air. Moisture doesn't naturally exist like high up in the atmosphere, so you have to raise it from the ground. Lift is the reason why, oftentimes if you've lived in Arizona, Tucson for a little while, you probably have noticed that thunderstorms tend to start over the mountains first and then kind of move over toward the city. It's because the lift happens over the mountain. And then finally, instability. Basically, if the more unstable an atmosphere is, the more aggressive you'll get that motion up and down the atmosphere. So that's all important in terms of creating a thunderstorm. So bringing it back to climate change, a global warming world will influence two of these factors, and that's moisture and instability. With rising temperatures, that'll increase your instability. It's just one of those natural features where you're more unstable with a warming environment. And with moisture, as you all like learned in chemistry probably, warmer air masses can hold more moisture than a colder air mass. That's just the way it works. So with a warming world, you should see potentially more moisture in thunderstorms and a more unstable environment. So there are some considerations with severe weather, which is why I mentioned that it's complicated might be the best answer. The real, one of the tricky situations right now for us is that like we don't have a really good sense if thunderstorms are getting stronger or if they're getting more widespread. And the reason why is because thunderstorms with these really kind of smaller scale features and impacts, you really need to have eyes on the ground, boots on the ground that observe these impacts to be able to say, okay, things are getting worse or things are getting better. And to have eyes on the ground, like you need storm reports, right? Well, storm reports are better now than ever before, and you can thank these devices for that. A lot of our tracking goes back to 1950, and obviously cell phones did not exist in 1950. There was no social media, no internet. So when people got hit by a tornado, you just kind of dealt with it. Or you saw hail, you saw damaging winds, whatever it might be. It was just, it happened. So the reporting was very slim back then. And you can kind of see that in these charts, right? So going back to 1950, here are all our tornadoes that were reported. And you do see an uptick in the trend, but how much of that really is, an increase in vulnerability, an increase in infrastructure. There are more cities and homes now, more cell phones, more eyes being able to see these tornadoes. We don't have a really good answer for that. So the trend is really difficult to predict here with severe weather, and that's just kind of the reality. There are some features that we can glean, though, from recent decades, and one of them is the location of tornadoes. So I'm sure we all learned in grade school and middle school that the traditional tornado alley is viewed as the Great Plains, right? So Kansas, Oklahoma, Texas, those areas are tornado alley. The reality is what we're learning is, and they still see a lot of tornadoes, but what we're seeing in recent decades is that there's actually a trend of more favorable tornado environments shifting to the east and south over time. So where they used to be over the traditional tornado alley, it's been trending over toward Mississippi, Alabama, Tennessee, Kentucky, that general area. And this has been studied several times. There's many research papers that have been hinting on this. That becomes a problem when you relate it back to health, right? Because Tornado Alley, those folks have built up their infrastructure planning for tornadoes. And if they for fewer of those and more tornadoes now are in the city, I don't have precise statistics, but I guarantee you there are more mobile homes, infrastructure that is not built for tornadoes happening in places that are now getting a whole lot more tornadoes. So you're seeing probably a lot more damage, a lot more injuries, a lot more fatalities that are occurring in locations that were not traditional tornado alley locations in the past. And that's something that we need to think about. Obviously, the deep south, the southeast, is a very socially vulnerable location. So they're already hitting places that you already have a lot of homeless people, again, mobile homes, that sort of thing. So it all kind of just gravitates to less resilient communities because of this shift in climate change. I'll touch quickly on the monsoon because there's a lot of uncertainty related to it. But if you aren't familiar with the basic physics and mechanics of the monsoon, what happens basically here in the Southwest is that the reason why we have a monsoon to begin with is because we have usually a very hot and dry May and June. That sets up this high pressure circulation over the desert Southwest. Oftentimes it's centered right over the four corners, so that's where it's usually kind of depicted. But with a high pressure system, circulation around it is clockwise in nature. And the high pressure becomes so large that it starts to draw in moisture from the Gulf of Mexico and from the Gulf of California. And that moisture that you're drawing in from this really huge high pressure system is what starts to bring the moisture, the thunderstorms that occur during the monsoon here. And I will say that, so that's part of the reason, like the moisture, the instability and all that, that's why we start to cool down in July, August, that sort of thing. And you heard Art mention in the previous presentation that July of 2023 was the hottest on record. It's because this high pressure system, or like the circulation didn't really set up. We didn't get the moisture, so we just ended up heating up. The sad news about all this, and again, with the climate change stuff, there isn't much consensus with climate change predictions about the monsoon. Unfortunately, we don't know. But the one consensus that it seems like the research is gravitating toward is that most projections are saying the monsoon will start later and end later than what we're used to. We're used to it starting roughly mid to late June and then running through September. And now prognoses are saying that might be delayed starting July, August timeframe, and then pushing it back to October-ish. That has huge ramifications on especially extreme heat. In the absence of moisture in the monsoon, our hottest months would be pretty much like anywhere else, June and July. If the monsoon starts later in the year, then you're talking about June becoming even hotter, July becoming even hotter. And like the charts that Art was showing with those extreme temperatures in June and July, that's going to become even more exacerbated with climate change. So that's the one area that's a lot of concern, to be honest, if we're talking about monsoon and climate change. Yeah, I'll just leave it there for now. Does anybody have any questions about just severe weather, monsoon, that sort of thing?
Is Arizona is the most water that we get during monsoon season when in terms of like total water rain?
It is, yes. I think it's roughly 2/3 or so that we get during the monsoon, and then roughly 1/3 or so during the winter. And for what it's worth, like there aren't really good prognoses about how much the changes in precipitation amount with climate change. I've read one study where they relate there was an era way back in prehistoric history called the Pliocene era. This was millions of years ago, and carbon records dating back that far suggest the Southwest was much hotter than it is now back in the Pliocene era. And they also suggest that it was much wetter during that time frame. So people are starting to think that the Pliocene might be a good analogy, and a hotter environment for the monsoon might actually mean much wetter conditions for us. All right, I'm going to go and move on, and I know that we don't have too much
Sorry,
time
I
left.
just have one more question.
Yeah.
So I saw that there's like a new technique that's being used. It's called like cloud seeding. I'm curious about what your opinion is on that and how that'll like impact our storms.
So that's a really good question, and I'm surprised that you've even heard of cloud seeding. So for everybody in the audience, the basic premise of cloud seeding is, it goes back to the basic premise of how you get raindrops to fall, to form. When you evaporate water into the atmosphere, and if you want a cloud to form, that water has to condense on a small particle of some sort. It might be dust, it might be some sort of atmospheric particle. Those are called hydrometeors. And the premise of cloud seeding is that you put a lot of these hydrometeors there. I think a lot of people use like sulfur iodide or something like that into the atmosphere. That gives more particles for like atmospheric moisture to condense on. And there are benefits to that. People have been doing that, I think, in California to try to squeeze out more moisture out of the air to get more precipitation in the reservoirs during drought season, that sort of thing. I think there are benefits to cloud seeding. It has to be done in kind of a smart and environmentally safe way. I will say that like another strategy that I've seen people use cloud seeding for, there are airports that historically are very significant prone to fog. And cloud seeding, you can actually use cloud seeding to basically get rid of the fog by dropping some of those particulates into the air and basically condensing and precipitating all of that fog out of the air. So that allows for airplanes to fly into otherwise unsafe conditions. So there are benefits to cloud seeding. I know that there are also, it's controversial because, you're pumping chemicals into the air. And I don't have a good sense of, like, I'm not an environmental scientist, so I don't have a good sense of like long-term environmental impacts due to that. But from like a precipitation water management standpoint, there are benefits to it. Hopefully that answers your question.
Yeah, thank you. It's something like really new, so I was just curious.
Absolutely, yeah. Okay, great. We're going to move on to ocean circulations, and we'll skip the poll everywhere here. Like you'll probably know what the answer is. More extreme, yes. A quick show of hands. How many people are familiar with Gulf Stream or the North Atlantic Current? Same name. You may have heard about this, middle, high school. Okay, that's totally fine. So it's basically what the Gulf Stream is. It's a ribbon of warm ocean water that starts off of the coast of Florida, and it is a stream of ocean that carries warm waters up to northern Europe. And this is really important, and it's the reason why, when you think about the climate of Great Britain or Northern Europe, it's at the same latitude line as Canada. And if you wonder why, okay, why is Great Britain then not the same climate as, interior Canada, where oftentimes during the winter it's minus 20, minus 30, minus 40? Well, it's because of this. The Gulf Stream is an important ocean current that brings warm, moist, warm waters from the Gulf of Mexico up to the North Atlantic Ocean. And this is an integral way to transport temperatures. For what it's worth, I mean, when you think about like the seasons of Earth, it all starts with the tilt of the Earth, right? So there's always going to be a deficit in temperature, deficit in the heat balance at the poles, and there's always going to be an excess at the equators. It's just the tilt of the poles, and that's just the way it works. So Earth is always trying to achieve an equilibrium in temperature, and the way to do that is using, the atmosphere to transport heat, temperature to the poles, and the oceans are doing the same thing, and that's what's happening here. So we're transporting an excess of temperature from the equator to the poles. Hopefully that makes sense. I didn't explain it too well. But this is a really, really important mechanism in terms of bringing an excess of temperature from the equator to the poles. And as it turns out, this is actually just a small part in the global circulation. It's called the thermohaline circulation. If you break down that term, you can kind of make sense of what it means. Thermo, temperature, and haline, it's saline, so salt. And so it's transporting both ocean water and temperature and salt. And it becomes important because, as you all are aware, again, going back to density type things, cold water is more dense than especially cold salty water is more dense than warm salty water. So what happens is when you transport water from the Gulf to the North Atlantic, by the time it gets to the North Atlantic where it's really dense, it'll actually start to sink down into the depths of the ocean. And that is the driver for a very large circulation called the thermohaline circulation. Completely global, and it's very important in terms of, again, transporting temperatures across the Earth. So again, the pump is in the North Atlantic, and this is also being impacted by climate change, we've learned. So one of the big reasons why this is being impacted is because this graphic you see on the upper right, that's Greenland. And as the ice sheets in Greenland start melting, you're pumping basically cold, fresh water into this area that's normally the pump, that's normally sinking. And that's disturbing this entire chemical balance between warm salty waters, cold salty waters. And the ultimate difference, what's happening is with this relatively cold recent snowmelt or ice melt, it's actually making this less dense and less likely to, for that water to descend into the depths of the ocean. That is, the ultimate effect is it's slowing down the Gulf Stream. Okay, so, and I don't have a graphic here, and that's totally fine. So what we found is that the Gulf Stream is slowing down. And research is showing that since the 1950s, it's weakened by 15%, which is a pretty substantial number. There is some leeway in that number. I've seen smaller numbers than that. So that's, there's a lot of uncertainty related to this. These climate models are suggesting that a complete shutdown of this is unlikely. But if you were to go through like the ice core records, it does show that this Gulf Stream, the thermohaline circulation, has actually shut down in the past. We're talking, tens of thousands of years ago. But that would have huge ramifications in terms of global climate, probably more so than anything that we've even talked about in terms of excessive or extreme heat, extreme cold, any of that. This could, again, part of the reason why Europe is moderated the way it is because of this Gulf Stream. And if it stops, then you could potentially be talking about an ice age in Europe, and you could be potentially talking about like extreme temperatures beyond what we can even imagine in the equators. So this is all just kind of hypothetical type stuff. I've read that there's some models that predict this could break down in just the next few years, which I think is extremely unlikely. But if this does break down, and again, I think it's a very small likelihood, but if it does, we're talking about like climate change in an arena that we can't currently imagine. So yeah, I'll just kind of leave it there with ocean circulations. And this is just a quick recap of what we talked about: extreme cold, severe weather, monsoon, and ocean circulations. Um, Again, hopefully you can kind of imagine how this relates to your futures as practitioners in medicine or whatever it might be. With a climate change world, whatever we're experiencing right now, if we think it's bad, it'll only get worse in terms of extremities. We're trying to build resilience to that, but climate change is just exacerbating some of our current challenges with weather. And we know that weather impacts a lot of what we do. So I'll leave it there. And I know I'm over time, so I'll pass it back to Dr. Drummond.
Cool. Thank you so much, Tom. Any questions for Tom?
I had a question. In terms of like for our monsoons and the hole, like where we get most of our moisture, is that coming from like the goal for like the oceans, or where do we get most of our pull or most of our moisture for our monsoons?
That's a great question. So for the monsoon, most of that moisture does come from the Gulf of Mexico and from the Gulf of California. It's a combination of both with that monsoon circulation. It's completely reversed during the winter for what it's worth. Like I mentioned, like a third of our precipitation comes during the winter. Most of that comes from the Pacific Ocean. So it's very different, but it's very interesting as well.